Now, the initial draft forward is 8 meters. Initial draft aft is 9.8 meters. Very good. Now, guys, look at the question. When the level falls by 30 centimeters or 2 meters, by looking at the question, can I say whether the ship is at single point contact or sitting completely? Can I say so, yes or no, and why? When level falls by 30 centimeters, can I say
single point, sir?
Why? What makes you say so?
Because the aft UKC was more than 30 centimeters.
So, but the level has fallen by 30 centimeters. No, then what do you know? How do you know what has happened after that? You're not getting my point.
We'll have to calculate.
So we cannot predict, sir.
So you do not know at what stage of grounding is the vessel. Am I right? It is like question number 2, question number 3 and 4, where we did not know what stage of dry docking was the ship in. Am I right? Correct?
Yes, yes, sir.
Have you understood what am I saying, guys?
Yes.
By looking at the question, you do not know whether the ship is going to be sitting completely or she will only be at one point contact when the level falls by 30 centimeters or the level falls by 2 meters, just by looking at the question. So it is similar to question number 3 and 4, where you did not know in dry docking whether the ship will be in critical ins period or outside the critical period. We don't use those words here, but don't you think there's an absolute similarity? Yes or no? Understood?
Sir.
So first thing we'll have to find out is when level falls by 30 centimeters, whether the ship is is the ship sitting completely or is the ship only in contact at the forward perpendicular? Likewise, when the level falls by 2 meters. In question number 2 and 3, how did we resolve this issue, guys? Would you like to recall quickly without looking back? In question 2 and 3 and 4, sorry, not 2 and 3, 3 and 4 of the dry docking, how did we resolve this issue?
By finding the
Draft.
draft at critical instant.
Finding P, sir, using TC.
So finding draft where? At critical instant.
Yes, sir, at critical instant.
No, at critical instant, finding which draft, bete? That's what my question is.
First point of contact.
First point of contact. No, the first point of contact.
First point of contact.
Yes, because when the level falls by 30 centimeters, you know the forward draft would have come to 7.7. You do not know what will happen to the aft draft. Am I right, guys, in this case?
Yes.
Yes or no?
Yes,
because wherever the contact is made, the depth and draft after that will be same. Am I right?
Yes, sir.
See, I'm not changing anything. The goalpost is not shifting. It is fixed goalpost. It's the same approach. So yes, somebody rightly answered. We have to find out at the time when she just sits overall, the draft at the forward perpendicular, that is the forward draft. Why? Because that is the first point of contact. Understood, class? Understood?
Yes, sir.
Okay, I don't want to say anything more now. Can you give me P when vessel just sits overall? You know enough about it now. And if you can't, then you have to ask yourself some more questions why you are not able to.
414.9.
414.9 tons. I've just written it. I'm not saying it is correct or wrong. And now I give 30, 40, 50 seconds to everybody to calculate. And you have to be honest if you're not able to. Yeah, tell me, beta.
372.3 around.
3, so I'll write that all 372.3. Okay, at least you guys are calculating and doing something. Okay, you may be wrong, it's fine or right, but at least you're doing something, and everybody needs to work. And
Sir,
if you're not able
414
to,
decimal 85.
okay, that is 41 decimal 4.9, right? Okay. I know what mistake one set is making, one fundamental mistake, but don't worry.
372 decimal 3.
Okay, both the answers are there. If somebody has a third answer, you let me know. If somebody has a third answer to this, I will note down that also. Two answers I have already noted down. Now I will ask the class, anybody who is not getting any of these two answers, guys. Anybody in the class who is not getting any of these two answers? Because then
414.9.
no. Is everybody getting either 414.9 or 372.3, or is there somebody who does not know what is to be done at all?
सर मेरा नहीं आया सर.
क्या आया तुम्हारा? तुम अपना आंसर बताओ. Give me your answer.
सर 85 आया.
अंजी
सर 85 आ रहा है.
85 आ रहा है, ठीक है. ओके 85 लिख दिया मैंने. Okay, how did you? Okay, anybody else who has not, who doesn't know? See, if you own it, you will learn it. If you don't own it, I don't know whether you'll learn it or not. I have no idea. Okay, tell me, how did you get 85 first?
सर ट्रिम चेंज निकाल के सर किया था.
Okay, what is the trim change? Let me see one thing at a time. What is the trim change when she sits overall?
सर 1.8
Meters by?
1.8 meters by stern sir.
Is it so?
नहीं 1.8 meters by head लिया था.
Is it so? Read the question, full question in that. Read the full question. What is the trim change for the vessel to sit completely on the seabed in the? अरे भाई तू जवाब तो दिया कर जब मैं बोल रहा हूँ. I can't keep
Sir.
speaking this.
नहीं सर एक मिनट सर.
I cannot be talking to walls. I have to talk to human beings.
Sir not able to make out sir.
Can you read the question completely from beginning to end? Loudly. Can you read it loudly?
A vessel of length 148 meters, LCF 70 meters, draft forward 8 meters, draft aft 9.8. TPC 32, MCTC 264 lightly grounds on gently sloping bed. Sounding taken at that instant should forward depth 8 meters and aft depth 10.9 meters.
Okay, no, okay, fine. Stop here. What does this part convey to you? What does this part convey to you?
So there is a sloppy ground.
How much?
2.9 meters.
2.9 meters. So when the ship sits completely on the seabed, what will be her trim?
2.9 meters. Right, sir. Shit.
You
Yes, sir.
should
We
now-
did same that we did in the.
Because after the class, you did not care to go through the question again yesterday. Problem lies there.
Thank you, sir.
Those who are getting confused between 414 and 372, I know I'll correct that. That's not an issue. But
नहीं
if
सर
you're
वो 372.3 आएगा.
okay, never mind. It's okay. That we'll see. Okay. So the initial trim, guys, the ship has an initial trim of 1.8 meters by stern. Trim of the ship when just sits overall will be 2.9 meters by stern. That means the change in trim required for the vessel to sit overall is 1.1 meter by stern. That is 110 centimeters. Am I right?
Yes, sir.
So my friend is
Yes,
not
yes.
only my friend is not only making mistake about this, Inder is also making mistake about the fact that he's taking trim in meters and not in centimeters. Even 1.8 he did not take in centimeters. Am I right, Inder?
Yes, sir. I did this mistake.
So
Jaldi
then,
jaldi.
then these are blunders you are making, no? A, you are not taking the right trim change. Two, you are still not converting trim into centimeters. तो कुछ पढ़ ले भाई घर पे. Put in some effort.
Yes, sir.
Okay, guys. So 110 centimeters is the trim change. Is that okay with everybody in the class?
Yes, sir.
Now, what will cause this change in trim? This P will cause the change in trim. Now, look at the line diagram. Using trim type A concept, trim change in centimeters will be equal to P into what will be the lever? Lever will be the distance between
7.2.
forward perpendicular and center of flotation. I can call it as FF upon MCTC. Am I right, guys? Yes or no?
Yes,
This will be P at that time will be trim change 110 centimeters, MCTC 264 upon FF. The length of the ship is 148, LCF is 70, so FF is 78 beta. Divide by 78. How many tons is it coming? Is it 414 or 372?
372.3.
37.
Okay, 372.3. Is calculation of P clear to everybody when the ship just sits overall? Yes or no?
Yes, sir.
Clear, class? Now, go back to your trim type A concept. If I discharge 372.3 tons from here, how much will be the draft forward? That is what you want to find out. You want to find out the draft forward when she just sits overall. Why? Because that is the first point of contact. So you know the forward draft initially 8 meters. You know how much weight is discharged. Using that, now you know from where the weight is discharged. Can you please find out how much will be the draft forward based on trim type A? I'm only giving you the lead. Processes we have done enough number of times, guys. Can you please find out what will be the draft forward when the vessel sits overall for the first time?
$7.324.
I'm just taking down 7.324. Okay. Anybody else in the class? Quickly, guys, we have to, though I have enough time, but still it should not be taking that much time, you know. Who wants to participate in guiding me through in calculation? Anybody who doubts himself and would like to volunteer to participate? Any one person? Anybody? No one wants to participate. Okay. Then it becomes easier for me. I can run away with the solution beta. You are giving me a easy pass.
Calculate mean rise, sir. We'll calculate
Yeah.
mean rise.
So basically your draft forward initial is 8 meters. When you discharge 372.3 tons from there, it will have two effects. One will be mean rise, which will be obviously minus. What will be the trim change, guys? We already have it on, we don't have to calculate. It's already known. What is the trim change caused by this P?
1.1
1
1.1
meters
centimeter.
by
stern.
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 So in this case, TF will be added or TF will be subtracted.
Subtracted.
Subtract.
It will be TF of trim change minus, and this will be the draft forward when vessel just sits overall. This will be the draft forward. Can you calculate mean rise? 372.3 divided by TPC of 32 and give me in meters. 0.116.
0.116.
Oh, okay, 116. Then trim change is 1.1 meters. Guys, how do you calculate TF? What is the formula for TF? TA, sorry. Formula for TA is, in this case, trim change into AF upon L. Am I right? Yes or no?
Yes, sir. Yes, sir.
So either you can calculate TA and subtract from 1.1, which will be lengthier. In this case, you can straight away calculate, because it's all ratio proportion. It is no rocket science. What you can do is this. This is TA. And in this expression, this is aft perpendicular. If I make it forward perpendicular, then this A also becomes forward perpendicular. So I can directly calculate TF. TF will be equal to trim change is 1.1, FF is 78, length is 148. So I can directly get TF and save time. How much is TF, beta?
0.580.
580. And when you do this, you will get the draft forward. What answer are you getting? Is it 7.32?
7.304.
7.304.
7.304.
304. Okay, 304. Okay. Is this calculation clear to everybody, or anybody has any questions to ask? Let me know. Is it clear, beta?
Yes,
Class?
sir. 304.
Yeah, is the concept understood? We did not know whether the ship is sitting or not. We have to first determine that, for which we found the draft at the first point of contact, and that is 7.304. I'll show you this working. Slope of the seabed 2.9. First, to find our draft forward. Why at forward? Because that is, you don't have to write all this, because that is the first point of contact when the vessel just sits overall, for which the trim change is 1.1 meters by stern. We have already discussed it. Guys, if I show it here, half of you will forget in no time. If I do it in hand, by talking to you, you will probably, some of you will at least remember, if not all. This gives us P 372.3 tons. So those who are getting 4.4, they were taking AF. That is the mistake they were making. Hopefully they will not make that mistake going forward now.
Yes, sir.
Yeah. And then draft forward will be initial draft forward minus mean rise minus TF likha hai. You have written TF, but ask yourself TF of what? TF of the trim cost. So TF of the trim cost, and that comes to 7.304. Is it okay with everybody? Yes or no?
Yes, sir.
Yes, sir.
So when the depth forward, when the draft forward and depth forward, because they will both be reducing together because the contact is made. When they both reach 7.304 meters, vessel just sits overall. Does everybody agree with this statement of mine? Yes or
Yes.
no?
Yes, sir.
Okay. Now, with this, now we go to part 1. In part 1, what is the fall in level?
30
Fall
cm.
in level is 30 centimeters. When level falls by 30 centimeters, which draft can you comment upon? Which draft do you know?
Forward 7.7.
Does everybody agree with him, or is there an issue?
Correct, sir.
So forward draft in part A will be equal to 8 minus 0.3, that is 7.700 meters. Compare that with 7.304. When the forward draft comes to 7.304, the vessel will sit on the seabed completely. Right now, your draft forward is 7.7. So in part 1, is the ship sitting completely or at a single point contact?
Single point contact.
Single point.
Okay, so you will make an inference that the vessel is at single point contact. What has happened? This is now quite like question number 3. In question number 3 of dry docking, the vessel was at single point contact at the required draft. Am I right, beta? Yes or no? Where the level had fallen from 5.8 to 4.8 dry docking, question number 3. Correct?
Yes.
Yes, sir.
So now make the line diagram and it will answer your question. This is aft, this is forward. P is acting here. How much is P? We have to find out. What is my initial draft forward? 8 meters. For which, how much is the draft forward for which I have to find P? 7.7. Here is center of flotation. This distance is 78 meters. Why? Because this is given as 70 meters. We know the TPC, we know the MCTC. Now, we can make an equation in which draft beta now?
Forward draft.
Overdraft, sir.
Now you understand why so much time was devoted to trim type A, right beta?
Hanji, sir.
Okay, so final draft forward 770 is equal to 880, 800 the initial draft minus mean rise P upon TPC. How much is
32.
the TPC in the question? 32.
32.
Minus TF of the trim cost. When you switch the sides, what will it happen? It will become 30 centimeters. 30 is equal to P upon 32 plus TF. We just learned how to get TF. TF is equal to, look at the diagram. It is it is trim change into FF upon length. Correct? That is how you get TF. Correct, Peter? Am I right?
Yes, sir. Yes.
And now, how do you get the trim change? Look at the line diagram. TC. Look at the line diagram. P into FF
upon
upon
MCTC.
MCTC. This is the trim change, guys, and into FF upon length. Am I right?
Yes, sir.
Do you agree, guys?
Yes, sir.
Yes, sir.
Okay. This now we are able to put the values. 30 is equal to P upon 32 plus P into FF is 78. MCTC is how much? How much is it? 264. FF is 78. Length is 148. And solving this, you can get P for part 1 of the question. Am I right, beta?
160.5.
160.5 tons. I will give you time to calculate though if you and review if anybody has a doubt. See on the I can show it on the next slide, but then once the slides start coming, it becomes so fast that many of you will lose connect. So please see that you remain connected with the pace, you remain connected with the question.
298.64.
Sorry, beta.
Sir, mine is coming 298.64.
Both of you can check who's right, who's wrong.
160.5.
160.5. Check again.
160.5.
So look at your calculation. Maybe you are not using the calculator correctly, beta. Because values are written on the screen. There cannot be any other reason.
160.45.
Or the 4, 5 will become 5 only, na beta 0.5, right?
Yes.
Yes, sir, 160.5.
So if you remember in the question I had added, what will be P? For part 1, P will be 160.5. What does he want? He doesn't want P, though I had added. He wanted drafts forward and aft. So guys, now the draft can be obtained in 2 ways. Let me first show you this calculation of P. I've already explained both the methods, but I'll again do it once more. This I have just explained. This I have just explained. If anybody does not understand anything, let me know. Does everybody agree with whatever is on this slide? We have discussed in ample detail, beta, just a while back.
Yes, sir.
Okay.
Excuse me, sir.
हाँ
So,
बोलो.
Sir, ये जो question अगर exam में can we calculate the value of P in both the cases and compare like if the value is compare the value of P's and if it is coming less अगर वो कम आ रही है सर अगर vessel बैठा है पूरा slope पे तो automatically वो float कर रहा है तो ऐसे भी check कर सकते हैं ना सर?
How will you calculate P unless you know whether she is sitting completely or not? Which method will you deploy?
Sir, the same method which you
Yeah,
showed.
you tell me this answer, whatever we got on the calculation a while back.
हाँ जी.
Okay. What are you saying? Tell me now from beginning.
Sir, initially we will calculate the value of P. जैसे ही vessel पूरा.
Well, what answer did we get for that? What answer did we get for that?
372 point
Okay,
something.
then compare it with what? Please tell me.
We will compare it with this 160.5.
How did you calculate 160.5? By assuming that it is not sitting.
Yes, sir.
So is it easier to go this way and then realize that you are on a wrong track and then redo the question, beta?
नहीं sir, this we will compare कि अगर ये value उससे कम आ रही है तो
but why did you choose this way to calculate P? You could have chosen the P by thinking that she's sitting completely, then what will happen? Which one is easier? You tell me now. Suppose you find it is not there, then what will happen? You'll abandon this process? Yes or no?
Yes, sir.
What will happen if you find that you did this part assuming that she's at a single point contact and you end up finding she's not at single point contact, she's sitting, then what will you do? Tell me.
Then calculate again this thing.
So does that seem to be making sense to you?
No, sir.
फिर अगर किसी चीज को लॉजिकली कर लोगे तो तुम्हें उसमें प्रॉब्लम है?
No, sir.
If you can calculate without any assumption, then I could have reviewed that method. But you are calculating something under some assumption. Why are you doing so? Correct?
I was thinking कि दो ही केस हो सकते हैं या तो
अच्छा, फिर what will happen? What will happen? Then you will do the same exercise for part 2 also. Then you will be repeating it in 2 parts separately. Yes or no?
Correct, sir.
So, bhai, har part mein you want to increase your work scope and keep going back and forth, Akshay. If you do this, this will only address the issue about part 1, correct? You will repeat the same shit with part 2 also. Am I right?
Yes, sir. Correct.
What logic does it make? Tell me. There has to be some game. So what benefit are you getting out of it? Tell me the benefit. See, either the two methods should be at par or yours should be better for any change to be considered. I don't see your method being at par also. Forget about being better. Okay. Okay, guys. So now.
सर ये वाला क्वेश्चन हम हाइड्रोस्टैटिक ड्राफ्ट लेके नहीं कर सकते, मतलब जैसे हाइड्रोस्टैटिक ड्राफ्ट फाइंड आउट करके वी कैलकुलेट देन दिस
क्या हाइड्रोस्टैटिक ड्राफ्ट?
सर फॉरवर्ड एंड आफ्टर ड्राफ्ट वी कैन कैलकुलेट फ्रॉम दैट आल्सो. अगर
वो कैसे? गिव मी द कंप्लीट प्रोसेस. अंधेरे में तीर मत चलाओ ऐसे. कैसे हाइड्रोस्टैटिक ड्राफ्ट?
सर जैसे वो लास्ट क्वेश्चन हमने डिक्लेरेटिव वाले क्वेश्चन क्वेश्चन में किया था.
यार तुम इसके नहीं, इसमें बताओ क्या करना चाह रहे हो? टू फाइंड आउट वेदर शी इज सिटिंग कंप्लीटली और नॉट. हाउ व्हाट डू यू वांट टू डू? Answer that much part of the question, that you are saying that we can find some other way that she is sitting completely or not. Am I right in that?
Yes, sir.
So what is that method? Explain to me step 1, because the other person explained. Now you explain. What steps are you talking about? Don't say like. Give me the complete solution.
ठीक है सर
No, give me the complete solution.
सर नहीं वो जैसे पहले दोनों का
Just जैसे नहीं, इसको ये क्वेश्चन तुम्हारे सामने है, ये क्वेश्चन pick up the values from the question and say this is what I have picked up. Next I'll calculate this and this is how I'll make an inference. Tell me what will you do? No, not like. Let's talk very
हाई ड्राफ्ट निकाल के
initial high
generally-
draft. Are you talking of initial high draft? Which high draft?
initial only
Which
sir,
high-
initial.
Which high draft you want to calculate? Please tell me. I'm writing here. Which high draft are you talking about? Tell me.
तो नहीं वो डाउट आया था क्वेश्चन में जैसे
Arey,
कि
I'm asking. So give me the process. No doubt. Then only I'll understand what you want to say. Problem is you yourself don't know what you want to do. Tell me, which high draft are you talking about? Initial high draft, shall I write? इंदर फटाफट बोलो, मेरे पास इतना टाइम नहीं होता बेटा बार बार एक चीज को 6 बार पूछने के लिए. You had some process in your mind. Let me hear your process because then you'll say I was not heard.
सर if I find out the high draft मतलब
Which
दोनों
high
का
draft? Which high draft? बेटे?
initial height
Okay, मैंने लिखा. Okay, the first thing you'll do is find the initial high draft. What will you do next? Now tell me next.
then we find out the pieces.
P when? P at which time?
P at critical instant मतलब वो
Okay,
main
P when
switch
she.
को-
Okay, P when
Sitting.
just right. So okay, then what do you want me to do? Then
So once we get this P mean rise निकाल सकते हैं इसे.
okay, then what do you want to do? You want to say high draft when she just sits overall, okay? Then
Yes, sir.
what else?
So mean rise में से इसको minus करके then we can get the this graph,
The
sir.
third point I've already written, high drafted when she sits overall. So when you subtract mean rise, it will give you high draft when she sits overall. So I've already done that, what you're saying. Next, after that. Whatever you're saying, I've calculated. So I'm doing whatever you're saying, exactly that. Tell me.
नहीं उसके बाद नहीं हुआ सर.
तो फिर डाउट क्या हुआ फिर?
Sir, question को approach I thought first he will do it.
No,
with the
but
height.
when you think you should have through and through process, no?
Understood, sir.
Sir, I took 10 steps, but I don't know whether I was taking in the right direction or not. Why you have to see up to the end, na? So at least take me up to the inference. If you're not able to take me to the inference, then it can't be called as a doubt. Then it is just a wandering mind, which is just wandering all over the place for no reason. बेटा तू मेरे साथ फंसेगा इंदर, ठीक है? Okay. So change in draft forward when the fall tides by 30 centimeters is 30 centimeters will be equal to mean rise plus TF. We had come the same thing by 800, 700 is equal to 770 is equal to 800. We came to the same thing that 30 is equal to this. We put these values and we got the value of P for part 1. This is the value for part 1. Am I right, guys?
Yes.
Yes, sir.
Now,
Yes, sir.
question does this I had added find the P, but question doesn't want it. Question says forward half drafts. Guys, I've already told you earlier.
7.7 and 9.974.
Okay, very good, beta. We'll see that. You can do it either way. Before Inder says, I would do like this, and then wherever there are alternatives, I automatically cover them, beta. One is you can calculate the high draft for part 1. So that means you calculate the initial high draft. The question is with you on your phones. Can you please calculate the initial high draft, guys? For 8 and 9.8. It will be 9.8 minus 1.8 into 70 upon 148. How much is it coming? How much is the initial height draft, guys?
8949.
8.9449.
944. So 95. Am I saying right? 8.945.
No, sir, 49. 49.
949.
48, sir.
8.949.
949.
Am I right now?
Yes, sir.
Fine. Now from this, if I subtract the mean rise, I will get the height draft for part 1. That will be 160.5 upon 32 TPC. Can you give me how much is the mean rise, beta?
0.050.
050. This is mean rise. This will give you height draft for part 1 of the question. This will be 9988. Please correct me if I'm making any mistake. That's okay. When we are using the height draft, which trim do you use, beta? You will use the trim. Which trim will you use? Okay, you don't have to do this. Okay, here you have a much more. Sorry, yeah. You don't have to go about beating right this. It's sorry, my mistake. No need of doing all this. We can do it straight. Okay. Now you know P. What was the formula for TC? This was the formula for TC. Am I right, beta? This one, correct? Yes or no?
Yes, sir.
Yes.
So trim change for part 1 will be equal to P is 160.5 into FF is 78 upon MCTC is 264. How many centimeters is the change in trim, beta?
47.4.
47.4 meters by stern. Correct, beta? Am I
Yes,
right?
by stern.
Everybody agrees? So this question
Yes,
you
sir.
can cut short like this. What is the initial trim? Because the drafts are required, so there's no point in breaking your head out there. Initial trim is 1.8 meters by stern. Trim change that has taken place is 0.474 meter by stern. What will be the trim for part A? Part 1. How much will be the trim, guys?
2.274.
2.274 meters. Correct, beta?
Yes, sir, by stern.
Yeah, by stern. Correct. Very good. What is the draft forward in part A? 7.700 meters. You already know that. So what will be the draft aft for part 1? Draft forward plus the
9.97.
trim by stern.
9.974.
9.974. So your answer would be for part 1, forward draft will be 7.700 meter. Draft aft will be 9.974 meters. Understood, beta? Yes or no?
Yes, sir.
Yes.
I'll clear it and show it to you. Trim change is 0.474 meters by stern. Initial trim is 1.8 meters by stern. So trim for part 1 will be 2.274 meters by stern. When tide falls by 30 centimeters, draft forward will be 7.7. Trim will be so much. Draft aft will be so much. And the answer would be so much. Is part 1 answer clear? Beta P we already know, right? 160.5. So that completes part 1 of the question. Yes or no?
Yes.
Now we come to part B. Part 2 is level falls. It's a MMD question, guys. Falls by 2 meters. Which draft can you comment upon for sure, guys? When level falls by 2 meter forward or after?
Forward 6 meter.
Forward 6.
Forward will be 8 minus 2 equal to 6 meters. At what draft does the vessel sit overall when the draft forward is 7.304? Am I right?
Yes, sir.
Yes or no? We have already
Yes, sir.
calculated in the beginning. Akshay,
Yes,
now
sir.
you
Yes, sir.
now you realize the same calculation is used here. We don't have to repeat it.
Outside.
Yes, sir.
Okay. So as the draft forward on vessel, just you'll write like this, just sitting overall is 7.304 meters. Vessel in part 2 is sitting overall. That means it is like vessel, if it was a dry docking question, as if it is outside the critical period. Am I right, guys?
Yes, sir.
Yes or no?
Yes.
Correct, guys? Class, yes or no?
Yes, sir. Yes, sir.
Yes, sir.
Okay. What will be the trim? So for part 2, what will be the trim of the ship?
2.9
2.9 meters by
by
stern.
stern.
That is the slope
Half
of the
draft
seabed.
8.9.
Draft forward is 6 meters. So draft aft will be 8.900 meters. No calculations required. Is it clear? Just look at the slide. I've already explained. If you still want to ask me anything, let me know.
But अगर P calculate करना तब तो we'll have to calculate it.
No. For P also, we don't have to calculate anything. We'll calculate P now. In this case, how will you get P?
Mean rise लगाना पड़ेगा ना उसके बाद.
Yes. So what?
How
So
much
you
is
have
it
to calculate.
overall?
How much is the initial I draft for calculation of P? We got a while back. 9.8 minus 1.8 into 70 upon 148. How much did you get? Initial I draft, guys?
8.8948, sir.
948 meters. Is that correct? Is he right, guys? Initial I draft was 8.948.
8.949.
949.
Okay, 949. Okay. High draft for part 2. We don't have to go with mean rise. It will be half draft is 8.9 minus the correction. Trim is 2.9 into 70 upon 148. How much is the high draft for part 2, guys? How many meters? How many meters is the high draft for part 2? How much it comes?
7.528.
7.528.
Okay. Guys, high draft changes for on what reasons? For what reasons does the high draft change?
Density and displacement.
Is density an issue here? No.
No, sir.
So here there must be a change in displacement. May not be real, may be virtual. Okay, fine. So what is the mean rise? Mean rise is the difference between this draft and this draft. That is 124.1 meters, which is equal to 142.1 centimeters. Am I right, guys? Yes or no?
Yes, sir. Yes, sir.
Yes, sir.
And for rise of 1 centimeter, the weight required is equal to TPC. Into TPC, this will give you P for part 2, if the question wants, right, beta?
Sir, this calculation after she sits overall, उसके बाद mean rise consider करके नहीं होगा.
Huh?
Initially we had
Tell me the full method, then only I can comment. I can't comment on one point which you say and then go into silence.
That initially we had calculated that when P reaches 372.3, she will sit on the seabed.
हाँ,
So उसके बाद further fall will be equal to mean rise only, right? Sir?
yeah, so but which is easier? Is this easier or that is easier?
पर वो ऑलरेडी हमने कैलकुलेट कर रखा है ना, फिर हमें ये हाइड्रॉक्स निकालने का जरूरत नहीं.
क्या? ओके, फर्दर फॉल का कैसे निकालोगे बताओ मुझे. Tell me. Give me the process. What will I add to that, whatever you calculated? Give me the process, फटाफट. Then I'll tell you whether right or wrong.
Sir, once the vessel is sitting overall on the seabed, then further जितना भी water level fall करेगा, that will be equal to
कितना
mean
फॉल
rise,
किया है?
correct?
कितना फॉल किया है? Tell me कितना फॉल किया है? फटाफट ये बताओ.
Sir,
ये नहीं कि
7 point. Sir, forward draft हमारा 7.304 था when she sits overall.
हाँ.
And in final case में हमारा forward draft आ रहा है 6 meter. तो further जो rise हो रहा है, that is equal to 1.304, right?
Okay.
तो 1.304 को centimeter में करके we can just multiply by TPC, so we get P.
And then you have to add. And if you
Then we
forget
add
adding it,
this
then
P. Yes, sir.
you will
Then we'll
you'll
add
get
this.
the same answer. But if you forget adding it, which happens with most people, then you will have a problem. Method is correct. Okay.
Okay.
You want to go that way? It's up to you. Right, beta?
Yes, sir. मतलब आंसर सर स्लाइटली ऑफ आ रहा था, वही मैं पूछ रहा था कि सही है क्या. It's
That is
around 20
those are
ton.
rounding of issues. 1-2-3 ton का फर्क होगा, 2-3-4 ton का, not much.
Okay, sir.
So that is because of the rounding of your doing, na beta? Okay. Okay. So is this question clear, guys? MMD में कई बार आ चुका है.
Yes, sir. Clear, sir.
See, guys, sometimes even if there are multiple ways of doing a question, okay, you'll do what strikes you. But if you have acquired a certain level, then you should always be going for the one which is the simplest way of doing it. And somehow I feel just doing it independent of everything else, because suppose there was some mistake in calculating P there, that will also start bothering you. This one initial height draft is simple height draft. Final height draft is based on draft forward and aft. You can straight away get it. Anyway, you want to go through a different route, as long as you get the answer right, I have no issues. Okay. So that is question number 3. Here you saw the first point of contact changed from aft perpendicular for the first time, and it made a difference to the calculations. Why? Because we moved everything to the first point of contact, wherever it was. So please remember, first point of contact, awareness of it, figuring out which is the first point of contact assumes a lot of significance. If you make a wrong assessment, you will mess up the question. Question number 4. MV hinge ship drawing 5.8 meters forward and 8.6 meters aft in seawater, kg so much, FSM so much, runs aground lightly, again word lightly, on an isolated rock. The moment the word isolated rock comes, even if the question does not state further, it means it is a rock which is alone somewhere in the middle of the deep waters, and it's an isolated rock, implying that there is deep water all around. Is that clear, beta? So word lightly is well understood, isolated rock is well understood, right? Clear, guys?
Yes, sir.
So here you don't have to worry about the vessel sitting on the seabed. She will always remain at single point contact. Guys, from your knowledge of dry docking and grounding so far, if I need virtual GM at low water, what do I need to calculate first? What do I
P,
need
sir.
to calculate? P
P
when
loss.
P at low water, right? Correct, guys?
Yes,
Yes, sir.
How many ways of calculating P are there?
2 ways.
Two ways, sir.
W minus B and TC. In this case, which one you think is applicable? Look at the question carefully and tell me.
W minus B.
W minus
W.
B.
Okay. So what will you do? You will calculate the initial height draft and get displacement. That means you'll get height draft again for this and get the ship's displacement. That will be the ship's displacement. You will get the height draft for 6.1 and 7.5. You will get W minus P. Am I right, guys?
Yes, sir.
And you will get P. And for this, you will also calculate Km and you can close the question. Now see, I don't think there should be any doubt. When you're calculating this height draft, you'll take LCF for this mean draft. When you calculate height draft for this, you'll take the LCF of the mean of these two. Am I right, guys?
Yes.
Okay, calculate fatafat. First calculate the displacement.
High draft for first is 7.204.
Okay.
W is 1477.
Okay, we'll wait here now. I've calculated the first one. Let everybody come up to this level. If anybody has any problems, let me know. Everybody has got this?
Yes, sir.
Please get the height draft at low water and get the W minus P and Km, and you can close out the question. These will be the values for it. Get the virtual GM. This is one of the simplest questions that you could have come across. And as I told you yesterday, today I leave you on a high thinking that you have understood everything, but just be careful. Don't go overboard with that. Correct, beta. W minus P and Km mila. What is the GM you got? Please confirm the answer to question 4.
0.293 virtual GM.
Okay. Is he right, guys? 0.293. Is that okay? Class, are you good with GM? .293. Yes or no?
Yes, sir.
Are we good with question 4? Everybody is good with question 4, beta?
सर बस 1 मिनट सॉल्व कर रहे थे 2 मिनट बस.
Okay, good, you have said. Okay, let me know once you're done. Good, please do it. Beta, once you're done, let me know, please. Let me know once you're done.
ओके सर, हाँ सर हो गया था अभी कंप्लीट.
Okay, anybody who's still doing, please let me know.
Yes, sir. I'm doing the last step.
Okay, let me know once you're done. Let me know, confirm. Let me know once you're done. Guys, one thing I would like to ask you, why this question could not have been done with trim change? You knew the initial trim and you knew the final trim. Why this could not have been done by trim change? It could not have been done that much I'm telling you upfront. So don't start thinking that you could have done that way. Anybody?
Rosna, we
Point of
assume that
contact,
the values are constant.
we don't know.
Yes, that is correct. We do not know the point of
Point
grounding.
of contact.
Yes, we do not know the point of grounding, location of grounding, and therefore trim change could not have been used. Though we know how much is the trim change. We know how much is the trim change, still the trim change concept could not have been used to calculate P because you do not know the point of grounding. People make mistake in this. They automatically assume that she has run aground aft and they start solving with trim change. It is wrong. Is that clear, beta? Is that clear?
Yes, sir.
It can't be done by trim change concept because you do not know the point of grounding in the question. It could have run aground anywhere, right from forward to aft. So unless you know where she has run aground, you cannot use the trim change concept, right? You don't know where the P is actually acting, right, beta? Okay. We go to question 5 then. Guys, may I request everybody to complete question number 1 and part 1 and part 3. You already know, and that will give you the, I always tell people, it will give you the confidence that out of 4 parts, 2 parts you have done on your own. Can you please calculate 1 and 3? I'll put the answers from the WhatsApp that I have shared with you so that you guys can check it. And don't keep sitting. If somebody doesn't know what is to be done, you can check with me. Don't just keep staring at the board here. Don't waste your time. It's very, very important for you. Let's finish all the questions today because there are only 2 questions left. Then we can call off the meeting, beta. The answer to the first part that you should get is 929.7 tons, right? And the answer to the third part you'll get will be 0.319 meters. So at least complete these 2 parts so that you know that 15 marks out of 30 you are able to score on your own. And if somebody does not get these answers, let me know. Anybody still stuck with part 1 beta? Part 1, everybody is through 9 to 9.7 or anybody still calculating?
Calculating,
Sir,
sir.
calculating, sir.
अरे भाई बेटा थोड़ा मुझे कोई फर्क नहीं पड़ता. I have enough time, but I think you need to speed up little bit, beta. I have enough time, but you have to look at your exam speed. You have to see. For me, it's okay. I can keep pampering you, giving you time, but exams will have mushkil. Okay, now part 1 is done by everybody? Yes or no? Any?
Yes.
Yes, sir.
Yeah, guys, if you own it, it's okay. I may give you some lecture, but it's fine. If you're still struggling with part 1, let me know.
Sir, finish with part 1 and 3.
Part 1 and 3, okay. Some of you may still be doing part 3. Am I right? Some are still doing part 3, guys?
Yes, sir.
Part 3.
Yes, sir.
Okay.
Correct.
Okay, I'll wait for you to complete. Please complete. And that should give you the confidence that 2 parts out of 4 you have done on your own without even slightest of direction. Okay, how far on part 3 now, guys? Anybody still doing it?
Sir, हो गया sir.
Okay, anybody doing it? Part 3, let me know, guys. Okay,
Sir, doing, sir. Doing.
okay, let me know, Madhu, as soon as you finish. Let me know, beta. Madhusudan done, beta?
Yes, sir. Already done, sir. Already
Okay,
done.
anybody else still doing part 3? Done? Okay, fine. So let me take you through these 2 parts first. Now, guys, when before grounding, we'll also calculate certain other parameters which will be required for part 2 and part 4. It's like LCF, MCTC. So those also will calculate together with the displacement. So we get the initial height draft 6.187, and we get these two particulars additionally. Right now you might have got this. We'll get these two also, and these are the particulars you get. These two will be used for the remaining two parts, part 2 and part 4. Okay. We do the similar exercise for this for W minus P and Km for that. We get the height draft after grounding, and we get Km for it and LCF for it, and we are able to get these values, and this gives us P, and using this Km of 8.512, we are able to close out the question. P is 9 to 9.7. That is answer 1. Answer 2. Okay, answer 3, let me show you first. Answer 3 is 0.319. Is that okay, beta? Yes or no?
Yes,
Correct, guys? Okay.
Yes, sir.
Now we go back to the question, and I explain you there before I come back here. Oh, never mind, it's okay. It doesn't make a difference. Okay. Okay. Guys, now, again, the answer lies in the line diagram, and line diagram trim type A is very, very handy for these questions. What is the trim of the ship when she is floating free, or initial trim of the ship, or when she was floating free? It's 2.4 meters by stern. What is the trim at low water at, this is how you'll write trim at low water is, or not trim, is it low water or it is trim after grounding? Sorry, it is not low water, it is after grounding, is 3.6 meters by stern. Trim change because of grounding is equal to 1.2 meters by stern. Am I right, guys? If I'm writing this, is it correct?
Yes.
What has caused the change in trim? Which parameter causes the change in trim?
P.
P, upthrust. Very good. Upthrust is responsible for change in trim. What are we treating the upthrust as? We are treating upthrust as virtual discharge of weight. Am I right? Yes or no, guys?
Yes, sir.
And now you'll understand why I'm fond of this particular method of virtual discharge. Because the same question, if you see in MV Hinship, it is done in a much lengthier way. Of course, your answer will not match with MV Hinship answers also. The difference will be about 2 to 3 meters, but both will be right because it does not make the MV Hinship answer any better than what you are going to get. Okay, so you'll see that if similar question, if you see in MV Hinship, they have done by initial displacement into initial LCG minus P into its LCG is equal to final displacement into final LCG. So that means every time with trim, you are calculating LCG, and it becomes a very, very lengthy process. I'm saying my answer through this method will not match with MV Hinship, but it does not mean I am wrong, they are right. Nor am I saying that I am right, they are wrong. Okay, both will be acceptable. There is absolutely no doubt about it. Okay, so now you see, guys, if the change in trim has to be by stern, firstly, which points acts as the fulcrum of the ship, guys? Class 1. From class 1, which point acts as the fulcrum?
F.
Center of flotation. Very good. So if I have to cause a change in trim by stern by discharging, should the discharge be from forward of center of flotation or aft of center of flotation?
Forward.
Does everybody agree? He says forward of center of flotation. Do you agree?
Yes, sir.
Okay. So this is what you have to first figure out from here, whether the grounding is forward of F or aft of F. So grounding is definitely forward of F. Here is my line diagram, guys. This is my forward perpendicular. This is my aft perpendicular. Here is the center of flotation. I know the LCF of the ship for these drafts. Okay. Now, obviously, the grounding has to be forward. Let us say at R, the vessel has run aground. So P is acting at R. Am I right, guys? Correct? Correct, beta? Yes
sir.
or no? And what is the value
Yes,
of P? What is the value of P we got in answer 1? Can you give me 920?
929.7.
929.7 tons upthrust is acting at R. That means it is like 929.7 tons is discharged from R. This distance is FR or X or whatever you want to say. We already know when you discharge this P from here, it will cause a change in trim by stern. And how much trim change it will cause? 120 centimeters. So we know the formula TC in centimeters. Will we look at the line diagram? What will be the TC formula in notations?
9 to
No,
9.7.
notations.
Notation P into
P
FR,
into
FR
upon.
upon MCTC.
Is he right, guys? From the line diagram, he's saying trim change is equal to P into FR or RF, whatever you want to say, upon MCTC. Is he right?
Yes, sir.
Yes, sir.
Trim type A, yes or no? Correct,
Yes,
beta?
yes.
Yes, sir.
So you know how much has the trim change taken place because of grounding? It is 120 centimeters. What is P? 929.7 tons. What is RF? We want to calculate. What is MCTC? For this draft, you'll have the value of MCTC that can come here. The only thing
170.
which is missing is RF. So you can get value of RF. Yes or no, beta? Am I right?
22.664.
22.664 meters forward of F. Forward of F. Is that correct? Please let me know if you have not understood the concept, guys.
Sir, one doubt, sir.
Bolo.
Yes, sir. MCTC, we have taken the earlier one.
MCTC concept.
This would take after grounding MCTC, correct?
Why? Are we sure that what have I been telling this on this context? What have I been telling at least 4 or 5 times? We have discussed this in the class. What have I told every time, Dheeraj?
Yes,
Can
sir.
you
We
repeat?
have.
No, what have I said? Repeat that. That unless you know that a particular for a certain draft is absolutely correct,
Yes, sir. Yes,
if
sir.
that is the case, you will take for that draft. If you have to assume a particular to be fixed through and through, then there will be error whether you take it for W or you take it for W minus P. Yes or no?
Yes, sir. Yes, sir.
So why keep complicating every time going back and forth? When we were calculating height draft after grounding, we took LCF for mean draft of 4 and 7.6 because we knew that mean draft will be more valid, right?
Yes, sir.
But here MCTC you are assuming to be constant from free floating to grounding, right?
Yes, sir. Okay.
Guys, is the FR value correct? Anybody who has any doubts, please let me know. Guys, we usually give the answer from after perpendicular AR this way. So whatever LCF you get for this, you add to FR and you will get AR. Am I right? Yes or no?
Yes, sir.
Correct. Now I'll show you part 3 of the part 2 of the question. This you have already done. These are the values of MCTC and LCF. Now use part 1, 9, now part 2 here. Let R be the point of grounding. I've already explained you in the diagram. Now see the reason. As the trim caused by grounding is 1.2 meters by stern, the upthrust, which is the cause of the trim, must act forward of COF. That is, R, the point of grounding, is forward of center of flotation. Do you agree with this? Yes or no?
Yes, sir.
Okay. Trim change is 120 centimeters equal to P into this. So P will RF is equal to trim change into MCTC upon P. This you all know, that gives you this distance of 22.664. AR, the point of grounding from after perpendicular, will be LCF plus FR, and that is 95 meters forward. Yes or no, beta?
Yes, sir.
Guys, now somebody may say, sir, in MV in ship, my answer is coming 3 meters. Look at from the practical perspective. Is the ship going to be aground only at one point? A point is basically does not have any diameter. It is a pinhole. So if the ship runs aground only at one point, then that will never bother you because you'll be able to handle that. Yes or no? The
Yes, sir.
ship will be sitting on a certain area. So whether I get it 95 here or I get 96 or I get 94, basically I am trying to figure out which part of the hull have I gone aground. Then of course you'll try to sound the tanks which may have been impacted or and all that. But what I'm trying to say is, if you see, this is much shorter. If anybody has done a similar question from MV in ship, I'm sure you will realize that it's a much lengthier process out there, right?
Yes, sir.
There, what are they doing?
Yes,
They
sir.
are getting
वो
before.
LCG ले रहे हैं.
Yes. So before grounding, they are getting displacement, and then using the trim, they are getting BG. Then from LCB plus minus BG, they are getting LCG. Similar thing you are doing after grounding, W minus P, BG, then LCB plus minus BG. After grounding, you're getting new LCG final, you can say, or initial. And then you are saying, okay, P tons discharged from LCG, whatever, X meters. And now you're getting X by principle of moments, right, beta? Correct?
Yes, sir.
So you have to
Lambda
apply the
का.
trim concept here. You have to apply the trim concept here. Then you have to apply the principle of moments here. It becomes much lengthier, which is not worth the time spent. So you can follow this shorter method, which will give you a reasonably good answer, which will be acceptable. You will not lose any marks. Don't worry. Is that clear, beta?
Yes, sir.
Okay. Now we go to the fourth part of the question. Fourth part. Sorry, before I go to the fourth part, any doubts on part 2, guys?
No, sir.
Okay. I'll take you back. So it is 95.006 meters is where she has run aground. I'll take you back to the first question part and I'll explain it here before I show it to you there. The rise in tide required for the ship to refloat, assuming that the reef is acting only at one point surrounded by deep water. Okay. Here is my ship, guys. This time I'll keep the ship horizontal and I'll incline the water line. When she was floating free, let us say she was floating free at this red water line. This WL was the red water line, where this draft was 7.4. This draft was 5 meters. And here was the center of flotation. After grounding, of course, we are assuming that center of flotation has not shifted. That we have already assumed when we were doing 95.06 also. After grounding, the forward draft reduces to 4 meter, aft draft reduces to 7.6 meters, and we know change of trim will not change the draft at center of flotation. So the new water line would be somewhat like this. Draft at center of flotation will not change, and this is now 7.6 and this is 4 meters. Do you agree with me, guys? Yes or no? W1 L1 is the water line after grounding, right? Correct, class?
Yes.
Yes, sir.
WL is the water line when the vessel was floating freely. W1 L1 is the water line after grounding. Where has the vessel run aground? Vessel has run aground at R. At how much distance from here? At a distance of AR equal to 95.006 meters. Am I right, beta? Yes or no?
Yes. Yes.
Now, you see, where is the vessel aground? At R. What was the draft of the vessel at R before grounding? This was the draft at R before grounding. Am I right, guys? Correct? Yes or no? Tell me, guys. WL is the water line before grounding, no? So this is the draft at R before grounding. Am I right?
Yes, sir. Right.
Yes, sir.
And blue is the water line after grounding. So this is the draft at R after grounding. Do you agree with it?
Yes, sir.
Yes, sir.
So why is the vessel stuck at on the rock? The vessel is stuck on the rock because the draft at the water level at R is less than the draft before grounding. That is why the vessel is aground. Am I right, beta? Yes or no?
Yes.
Yes, sir.
So if the vessel has to float free, this dr after grounding must increase to dr before grounding. The moment dr becomes equal to dr before grounding, do you think the vessel will be afloat? Yes or no?
Yes,
Yes.
sir.
Yes, sir.
Am I right? Class?
Yes, sir.
Am I
Yes,
right?
sir.
Vessel will be afloat if the draft at R rises from dr after grounding to dr before grounding, correct?
Yes, sir.
And for this draft to rise, what has to happen? The tide has to rise. So what is the rise in tide required? Rise in tide required for to refloat the vessel is dr before grounding minus dr after grounding. Do you agree with me, beta? If I get these two drafts, I'll get the answer to part 4.
Yes, sir.
Yes, sir.
Please let me know before we do get to the calculations. And before I rub it, oh, okay, I'll do the calculations here. You can take a screenshot of this question sheet if you want for later reference. Does everybody agree that if I can get these two drafts, my part 4 will be closed out? First, do you agree conceptually, yes or no?
Yes, sir.
Yes,
Okay,
sir.
now how do I get draft at R before grounding? Now, beta, how do you get draft at center of flotation? You get draft at center of flotation. Draft at center of flotation. This is not forward, this is center of flotation. You get draft of center of flotation, which is called as the height draft. I'm just trying to connect with what you know. You don't have to write it like this the way I'm writing. Will be equal to height draft. And how do you calculate? Half draft plus minus correction. Yes or no, beta? Am I right? This is how you calculate height draft. Yes or no?
Yes, sir.
Yes.
And what
Yes,
is the
sir.
formula for correction? It is half draft plus minus correction. Correction is what? Trim into AF upon L. Am I correct, beta?
Yes, sir.
This gives you draft where? This gives you draft at which location? This will give you draft at which
Center of
location?
flotation.
At center
At
of.
center of flotation.
Center of flotation. sir.
Flotation.
And in this expression, what is F in the AF? What does F in the AF stand for?
Center of flotation.
Center of flotation. What is AF? It is the distance of center of flotation from after perpendicular, correct?
Right, sir.
Now, I do not want the draft
Right,
at
sir.
center of flotation. I want the draft at R. Correct, beta? Correct? So what happens? This F is replaced by R. So draft at R will be equal to half draft plus minus correction, and correction will be trim into AR upon length. Do you agree? See, I have just connected it to what you already know, beta. By ratio
Yes, sir.
proportionate. When will be it minus? When the vessel is trimmed by stern. When will it be plus? When the vessel is trimmed by head. You know already that, right? Correct, class?
Yes, sir.
So DR before grounding will be equal to, what is the aft draft before grounding, beta? 7.4. Am I right? Correct?
Yes, sir.
Minus.
Yes, sir.
What is the trim before grounding? 2.4. What is AR? 95.006. We have already calculated. What is length? MV inship is 143.16. How much draft do you get, beta, at R before grounding?
$5.807.
5.807. Does everybody agree or anybody has any doubts?
Agree, sir.
Okay, now please calculate draft at R after grounding. I will write later. You give me the answer first.
5.211.
5.211. I don't know. You guys have to confirm. And that will be equal to draft after grounding is 7.6. 7.6 minus Y, because after grounding also the trim is by stern. How much is the trim? 3.6 meters by stern into 95.006 upon 143.16. Does it come 5.211?
Yes, sir.
And now you know rise of tide will be the difference between these two. So rise of tide will be, if those answers are correct, it will be 6, 9, then 7, 5. 0.0596 meters or more. The moment tide rises to 0.596 meters, P will become 0, and thereafter the vessel will float freely. Yes or no, beta? Am I right?
Yes, sir.
If you want to take a screenshot of this one, you can take it, guys. I've explained so that it makes sense to you rather than mugging up, rather than saying do this and do this and do that. You have to understand it so that you can reason out to yourself when you're doing it. Now I'll show you the calculation that I have done, and that will complete question number 5 then. If anybody has any question, in the meantime, you can think of it and let me know while I'm reaching the part 4 of the question. 3 we had already discussed, and here is the part 4th of the question. Guys, if you keep it simple, it will be very simple. Keep it logical. Line diagram comes very handy. Concepts of ratio proportion are very handy. You just have to be absolutely relating it to what you already know. And if it is okay with everybody, then I can go to the last question. Let me know, confirm that you are okay with this question, guys, everyone. If anybody has any concerns, let me know, please.
Okay, sir, with the question.
Okay. We go to the last part of the question, last question, in fact, and now you have to do it by yourself, guys, and then go with a high on a high, leave the topic on a high. MV Hinship is at a seawater anchorage, floating at 5.4 and 7.4, kg 7.7, FSM 800. During a falling tide, she lightly grounds on an isolated rock 30 meters above the forward perpendicular. So location of R is given now. The tide is exposed. She first runs lightly aground, and then of course, after that, the tide keeps falling by another 60 centimeters. Assuming that the hull remains intact and there is deep water all around, find the upthrust. Of course, if you get the upthrust, part 2 will not be an issue, and the drafts forward aft will also not be the issue. So only issue is getting the upthrust. Once you get P, I am sure 2 and 3 you can all complete. Yes or no?
Yes, sir.
Okay. Ask yourself a question. Which is the first point of contact? Which is the first point of contact?
So forward.
30
Forward.
meter of forward perpendicular.
Okay. R is the first point of contact, which is 30 meters after the forward perpendicular. Good. Okay. After the contact is made, what happens at the point of contact between draft and depth? What happens between them?
Both changes same.
Both change together. Okay. Okay. So guys, just for the sake of explanation, I'll make a line diagram, and you see the line diagram, the moment you can crack the line diagram, guys, your problems are resolved. And please don't leave out the trim type A problems. Let us say this is the after perpendicular. This is the forward perpendicular. For this high draft, we can find out the center of flotation. Let us say here is the center of flotation. Where has the vessel run aground? The vessel has run aground here at R. What is this distance? 30 meters. What is the total length of the MV Hinship? 143.16. So what will be AR? In the last question, we had calculated AR. Here indirectly, AR is given to you. 143.16 minus 30, 113.16 meters. Does everybody agree? Yes or no?
Yes, sir.
Now, at R, upthrust will act as the water falls. Let us say the draft at R is X meters when she is floating free. That means at light grounding or before grounding, draft at R is X meters. I don't have to, I can calculate it by simple that AR concept, but I don't have to waste time in calculating it. If I have to calculate draft at R before grounding, we all know how to calculate it. It will be the draft aft 7.4 minus the correction. Correction will be the trim is 2.2 meters into distance is 113.16 upon 143.16. Am I right, guys? This will give me draft at R before grounding, correct?
Yes,
or
sir.
no?
Yes, sir.
But I don't have to waste time. Let us say draft at R before grounding is X meters or X centimeters. Let's say it's X centimeters. What will be the draft at R at low water? Read the question and tell me.
X minus 0.6.
Minus 0.6.
X minus 0.6.
Okay, X is already in centimeters, so we'll make it X minus 60, right?
Yes, sir.
So after grounding draft here, this is before ground, this is before or on light grounding, both are same, right? This is at low water. At low water, the draft is X minus 60 centimeters, correct, beta? Am I right?
Yes, sir.
Guys, I know the initial draft aft. Initial draft aft is 7.400. The third part of the question wants this draft to be calculated.